Let's discuss the concept of independent events and get into just a little bit of probability. Looking at a deck of cards, we have 52 cards total, 4 different suits, spades, hearts, diamonds, and clubs, 13 cards for each suit, and those are all put in a row. It's very nice to use this to talk about these concepts. I set two events, as event A is drawing a red card, event B is drawing a king, and we're just going to draw one card at first. So to find probabilities, we're really just counting how many cards will fit the description. So a couple quick examples is P of A and P of B. In other words, the probability that event A happens, probability of drawing a red card. So our red cards we have right in the middle here. I can kind of shade those in like this. We see that's about half, right? That's a total of 26 cards out of 52. So that's exactly half. We could call that, let's call it a half first as a fraction. That's a reduced fraction. We could say that's 0.5 as a proportion, or that's 50% as a percentage. For B, and now I need to kind of erase that. Okay, so for B, it's the kings. That's down here on the right. We see that's a smaller percentage. There's going to be 4 of those out of 52. That would reduce to 1/13. It does not divide evenly, so it's approximately 0.0769. I'm going to round it to 4 decimal places, which would be the same as 7.69%. So that's a rounded percentage for that one. Now to talk about whether or not these are dependent events or independent events, we think about how does the likelihood change if we have a given condition. So the next thing I would want to find is the probability of A given B or the probability of B given A, either one of those. And I'm going to just use the fractions here. I don't need all these extra measurements of the same amount. So let's compare P of A to P of A given B. And so this is going to be the concept of conditional probability. We're saying we're drawing one card. We have a given A or given B here. Given that it's a king, what's the probability it's red? So we start with the part after this vertical line, given that it's a king. So first we're going to just say, well, how many kings do we have? Given B, we've got 4 kings. So now that's going on the bottom, right? We had B was 4, but now we're saying out of group B. And within that, what's the probability that it is red? Well, we look at just the kings here now, box that in, and we say here's 2 reds out of the 4. And so we're boxing that down and shading within the box. 2 out of 4 is a half. That's the same. These two things are equal. P of A and P of A given B. Let's try it the other way around. B given A. So that's given that it is a red card, A. Given that it's a red card. All right, so boxing in the reds, that's 26 possible cards I can choose from if I'm given that information that it's red. So out of 26, the king's probability of B, probability that it's a king, within that we've got 2 of them there. 2 out of 26 is 1 out of 13. So this is the best way, I think, to check for independence. Sometimes you have to do it conceptually. For example, let's say you actually do 2 things. You draw a card and you flip a coin, and you want to know if the flipping a heads has any impact on the probability of drawing a red. Well, those are 2 completely separate, and we would even say 2 independent events. One does not affect the other. Sometimes we'll come across scenarios where we draw 2 cards. Let's look at that example. If we draw 2 cards, it will be an independent event as long as we replace them. Now we're going to get into the probability of the intersection, or an AND probability, P of A and B. So this is also, sometimes we use the intersection symbol. We're saying both of these events happen in one instance. So that in the experiment, we're drawing 2 cards and we're replacing. So we draw 1 card first, and then we find the probability that it's red, we put it back and we shuffle it and we redraw. So we're returning the deck to a shuffled state where it's a random chance. Here, when we do AND probability, we multiply. And we'll talk more about the multiplication rule in a bit. But for this problem, what we would have is a red card in the first trial is half the deck. We put it back in and we're back to half the deck. And if I show my work there, it will actually maybe be a little better. That's 26 out of 52. Returning it to the deck, 26 out of 52. If I find the probability of A and B, same probability, but now I do not replace the card, I start with 26 out of 52, and when I get to the second draw, I've changed that deck. Now I have only 25 red cards out of 51. These probabilities are not the same. With replacement, you can actually use an exponent. You can just keep multiplying the same probability for as many draws as you have. If you do not replace the card, you have to adjust as you go. So we'll talk more about that when we get to that multiplication rule.